So in this problem, 100 college students were surveyed. 37 were in Math 101. We'll call this set A. 60 were in Math 114. We'll call this set B. And 17 were in both Math 101 and Math 114. So that's going to be the intersection. So the number of students in set A is 37. The number of students in set B is 60. The number that are in both was 17. Maybe they're a math major and they really love math, so they're taking 2 math classes at a time. So part A is asking how many students are registered in Math 101 or Math 114. So if you recall, this or means we're talking about the union of these two sets. We want to know what is the union of these two sets. So if we're talking about the union, we have to use the counting formula here, which says that the number of elements in A union B is equal to the number of elements in set A plus the number of elements in set B minus the number of elements in their intersection. The number of elements in their intersection. So what do we end up with here? So the number of elements in set A, that's 37. The number of elements in set B is 60. And the number in their intersection is 17. So when we do this math, 30 plus 60, that is 97. 97 minus 17 is going to be 80. So there are 80 students in the union of those two sets. 80 students are either in Math 101 or Math 114, or could be in both. Question B is asking how many of these college students registered for neither Math 101 or Math 114. Maybe they're a student who has already taken their math or met their math requirement, so they don't have to take a math. How many are in neither? Well, we know that 80 students are in either 101 or 114 or both. But how many students were there in total? Well, remember we said we surveyed 100 college students. So if we were surveying a total of 100 and we found out that 80 were in Math 101 or Math 114 or both, that means that we're left with 20 students who are not in either. There are 20 students who are not in either.